So welcome everybody. This is our final weekend in the Beyond Bohm Part 2 series, David Bohm and Philosophy. And we extend a warm welcome to Marij van Strien. Just a couple of Zoom rules before we begin. During the presentation, we ask that you turn off your microphones just to ensure a good audio quality. And for this reason, we may mute you if we hear some background noise. And in the second half of the event, you will be able to ask questions or make a contribution to the discussion. And you can use the raise your hand function that you can find under reactions at the bottom of your screen. And otherwise, you can physically raise your hand. And if I see you, I'll call you out. The chat is also open, and we do encourage you to use the chat, as it is a great way to share thoughts on the presentation with other participants. And finally, this session will be recorded. So today we have with us Marij. She is a postdoctoral researcher at Bergische University Wuppertal. After studying physics and the history and philosophy of science at Utrecht University, she obtained a PhD at Ghent University. Her research focuses on the relation between physics and philosophy, and in particular, the philosophical implications that have been drawn and can be drawn from theories in physics. And her session today is entitled, Why Bohm Was Never a Determinist. Welcome, Marij. I'll hand it over to you.
Yeah, thank you very much. I will start a presentation. Yes. Yeah, so my talk is titled Why Bohm Was Never a Determinist. I will argue that David Bohm actually was never a determinist, which is probably surprising to many people, because if Bohm is known for one thing, it is for having developed a deterministic interpretation of quantum mechanics, which he indeed did. I'm not intending to deny that he developed a deterministic interpretation of quantum mechanics, and the fact that he did develop a deterministic interpretation of quantum mechanics is really interesting, because it actually does show us that quantum physics doesn't force us to accept that nature is indeterministic. I do think that this is a significant thing that David Bohm has shown. Nevertheless, I want to argue that he was never actually committed to determinism. This is not what he was after. He was not really aiming to develop a deterministic theory of quantum mechanics. And he actually argued for a more nuanced account of determinism and chance. And I don't think that this is a development that's only to be found in his later work. I think traces of these more nuanced accounts can be found from the very beginning, basically. Yeah, so that's my aim for this talk. I will start with some general introduction. For some of you, this may just be things you already know, but I thought it would be good to have some general introduction to the topic. Then there will be the main part about whether Bohm was actually a determinist, and then I will close with saying something more general about the role of determinism in debates about quantum mechanics. So, to start introduction, we of course have to ask, what is actually determinism? What is meant by determinism? Sorry. So one way to define determinism in physics is the following. Determinism expresses the idea that all natural processes can be fully described through initial state and a set of laws of nature. So if you know the initial states of a system, then the laws of nature are mathematical equations which have a unique solution. That means they give a unique prediction for the future evolution of this system. So this means applied to the universe as a whole, that given the state of the universe at an instant, it is in principle possible to derive the state of the universe at all later times and also all earlier times. Actually, determinism usually goes in both temporal direction in most formulations. Or if you don't want to look at the universe as a whole, you can look at isolated or a smaller system. Then you have to assume that this system is perfectly isolated, and then it follows that given the state of a perfectly isolated system at an instant, it is in principle possible to derive the state of the system at all later times. So it's important to note that this is about what's possible in principle. So determinism generally doesn't say that it's actually possible in practice to give exact predictions for natural processes, because of course there is a limit to the accuracy of our observations and measurements, so you can never actually know the initial state of any system. But the idea of determinism is that if you would know the exact full initial state of a system, and you would know the laws of nature, then from this follows in principle the entire future evolution of the system, even if this is something that we can never actually do in practice. Yeah. So that's to definition of determinism. Now, Bohm is known for developing a deterministic account of quantum mechanics. Is this a good thing? Should we aim at developing deterministic theories? One reason why it may be a good thing to have deterministic theories in science is that there's often the idea if there's a failure of determinism, that means that you have an incomplete understanding. If you cannot give deterministic account of certain processes, that may just mean that you don't have a complete understanding yet of these processes. And this is related to the fact that if you ask what science does, what do scientists do? What do they aim at? They aim at figuring out how and why things happen and under what conditions phenomena occur. So imagine a scientist in a laboratory observing something. The scientist will want to figure out, why does this happen? What determines this occurrence? And if you just from the beginning say, well, maybe it's just chance, maybe it's just random, then you will never get anywhere with the development of science. So yeah, I think this aim at, or this drive towards deterministic theories, it can be understood as an aim of science, basically. But you may also ask whether we should not also worry about determinism. For example, there is often the idea that determinism would make free will impossible. If the entire future is already fixed, then how can we still have free will? Here, just as a remark, there are in fact many philosophers who argue that we can still have free will even if the world is deterministic. So it's not necessarily something you have to worry about, but you may worry about it. You also may worry about if everything is determined through fundamental laws of nature, are these laws all that matter? So if everything is in the end determined through the motion of atoms and everything reduces to the motion of atoms, this may lead to the idea that this is basically all that matters. So our thoughts and dreams are just illusions, and everything that's really there is just the atoms moving around. Again, there are good philosophical arguments also for saying that this is not necessarily the case, but yeah, it's something you can worry about. And also You can ask if the world is deterministic, can this give rise to anything, to something qualitatively new? Where again, you don't necessarily have to worry about it, but you can, and we will see that this is something that David Bohm also worried about. If everything is determined through a fixed set of laws of nature, then you may think that this means that everything will continue more or less the way it is, and there's no space for really fundamentally new things to arise in the world. Then, sorry. Oh, I got stuck. Yeah, sorry. So what about quantum mechanics? So quantum mechanics is well known that quantum mechanics in its standard formulation is not deterministic, but the way in which it's not deterministic is somewhat tricky. Actually, if you look at the theory of quantum mechanics itself, it describes a deterministic evolution of the wave function. Every system can be described with a wave function which develops completely deterministically. Just when you make a measurement, the wave function collapses, and you will measure, your measurement will have one unique outcome, and the theory of quantum mechanics cannot tell you what outcome you will get. It just can give you probabilities. So yeah, this indeterminism in quantum mechanics only comes in through measurements, and measurements in quantum mechanics are generally something quite weird, because the theory of quantum mechanics cannot actually tell you how the measurement takes place. It cannot actually describe the measurement process. And this is basically where all the weirdness of quantum mechanics comes in. The idea, well, the Schrödinger cats, where the theory just describes a superposition of a living and a dead cat, and only by measuring or observing apparently does the system get a definite state. So there's the idea that the world changes when you look at it. Indeterminism in quantum mechanics comes in through measurement, and measurement, you can say, is generally not the big open question in philosophy of quantum mechanics. How to understand quantum measurement? Is it human consciousness which makes here the difference if you observe things and they change? That's not necessarily the case. Also, I would say the large majority of quantum physicists would say that it's not, has nothing to do with consciousness, but still, there's not really an agreement of how to understand measurement. And this is, as I said, basically the big open problem. There are all these different interpretations of quantum mechanics, which are mostly different ways of accounting for measurement. So then Bohm, David Bohm actually developed a deterministic interpretation of quantum mechanics, which he proposed in 1952, and which goes back to similar ideas formulated earlier by de Broglie. In these interpretations, in this interpretation, there are particles which always have a well-defined position, and their motion is guided by the wave function. And this means that the state of a quantum system is always well defined. And when you measure the position of a particle, you measure just something that was already there. So the whole measurement process can be exactly accounted for and explained. I'm not going to discuss the advantages and the disadvantages of this interpretation of quantum mechanics. There's certainly maybe some difficulties to it as well, but when people like this interpretation, they like it mainly because it gives a full account of the measurement process And you can say that, yeah, it gives a complete description and enables a full understanding of what is actually going on. And yeah, what it means for determinism, it means basically that quantum mechanics does not tell us whether the world is deterministic. Bohm's interpretation of quantum mechanics has exactly the same predictions as the standard theory of quantum mechanics. Yeah, it cannot experimentally be excluded that this is the right account. So basically, we cannot say whether the world is deterministic or not. And yeah, as I said, I think that is really a significant result. That quantum mechanics is an extremely successful theory, and at the same time, it actually tells us very little about what the world is actually like, because there's a range of different interpretations which are all possible. Yeah, so much for the general introduction. Now we will come to the actual main part of my talk. Was Bohm actually a determinist? So the fact that he developed a deterministic interpretation of quantum mechanics does not necessarily mean that he was also a determinist. And to answer this question, I will look at what Bohm actually says about the topic, and I will do this chronologically, starting with his book Quantum Theory, which was published in 1951. So this book, as most of you probably know, is still, introduction actually to the standard account of quantum mechanics. So this is before Bohm developed his own interpretation of quantum mechanics. The book is not entirely standard, and you can already see actually traces of Bohm's own ideas, which he developed in more detail in later years. But yeah, largely when he talks about quantum mechanics, is still the standard account rather than his own. So what does he say about determinism? He says quantum mechanics is indeterministic, but he doesn't just say that quantum mechanics forces us to accept indeterminism. Or he doesn't say that quantum mechanics forces us to give up determinism. He actually argues that there is no reason to expect a physical theory to be deterministic. Classical mechanics was deterministic, and Bohm argues that this was very much connected to the use and development of machines and the idea of the world as a machine. And indeterminism is actually closer to everyday experience. So with quantum mechanics, we move away from this image of the world as a machine and move closer again to everyday experience. And in everyday experience, you experience that events often have causes, and a cause can brings a tendency towards a certain effect, but usually not with absolute certainty. So usually you cannot predict with absolute certainty what will happen. So therefore, indeterminism is actually closer to everyday experience. So that's in 1951 that this book appeared. In 1952, Bohm published this article in which he actually proposes his own deterministic interpretation of quantum mechanics. And yeah, so if we look at what Bohm actually says in this paper about the aims of this interpretation, we read that he thinks that there's something really wrong with the standard theory of quantum mechanics. What exactly is wrong with this is it requires us to give up the possibility of even conceiving precisely what might determine the behavior of an individual system at the quantum level. So here he does speak about what's wrong with the present theory of quantum mechanics is it doesn't tell us how things are determined. So yes, indeed, this does kind of point towards a deterministic view, but yeah, I think his aims here also already go deeper. So he argues that the present theory of quantum mechanics is based on the assumption that no objective and precisely definable description of reality is possible at the quantum level of accuracy. So I think that what he's actually after is a theory which enables an objective and exact description of what may actually be going on at the quantum level of reality. He's also explicit about the metaphysical assumptions behind his interpretation. It's based on the idea that the world is objectively real and that we can analyze and describe it. And also there's the idea that the world has an unlimited complexity. And this idea of an unlimited complexity, that's already a bit in tension maybe with determinism. Otherwise, I admit he does give a deterministic account of quantum physics here. Does that mean that at this point he was actually committed to determinism? If he was, it was only for a very short time, or only partly maybe, because yeah, this paper appears, yeah, as I said, his book on quantum theory appeared in 1951. This paper appeared in 1952. Then later in 1952, he wrote to a friend in the US that he describes the idea of a limitless number of levels of nature. And he writes that with this conception of a limitless number of levels of nature, the nightmare of complete determinism is avoided. So, yeah, this is the same year in which he developed his deterministic interpretation of quantum mechanics. Yeah, so how to understand this? So this is from his correspondence. 1952, Bohm had just arrived in Brazil after losing his position in Princeton. And he was corresponding with his friends back in the US, and some of this correspondence has been collected and published under the title Letters to Three Women. And yeah, I think here he formulates some interesting ideas. So in these letters, Bohm explicitly argues against the idea of a mechanical determinism. So there's what for him is the classical mechanical determinism means that nature consists of some fixed basic elements which move according to fundamental laws of nature. So basically all that ever happens is that these basic elements get reshuffled. That means that there is only quantitative change in nature is possible. Yeah, this is for him the conception of nature as a machine, and Bohm doesn't like this at all. And against it, he proposes the idea of an infinite number of levels of nature. So what does that mean? So it means, the world as at the level at which we conserve, the world at the level at which we observe can be described with classical mechanics. However, if you zoom in and look at matter on much more detailed level, you arrive at the level of quantum mechanics, where things look very differently. If you zoom even further, there will be again a different level, and this, Bohm says, he expects this to continue to infinity. So yeah, the elements at each level, they arise from a lower level. So if you have something like an atom, if you zoom in further, you will see that it consists yet of further parts. At each level, there are qualitatively new entities and properties. He also writes that it's not just that there are always, each level is, so to say, builds on a lower level, but also what happens on a higher level can then again have an effect on the lower level. And there is no fundamental level, so that means that nature is infinitely complex. And all of this basically implies that none of our laws of nature can be taken to hold exactly. So you can describe nature at a certain level, for example, the level of classical mechanics, and this may work quite well. This may work, you can get really reliable predictions, but there is a limit to it. There's always some inaccuracy because yeah, fluctuations at one level, at the lower level, may always have an effect on the higher level. So yeah, basically none of our laws can be taken to hold exactly. And yeah, we can never arrive at a complete description of nature. So it's really the idea of complexity that is central here. Nature is basically incredibly complex. He still argues for causality, and I think that's confusing a lot of people, because what does causality mean? I think causality is often taken to mean the same thing as determinism, but it can also mean something slightly different. And Bohm really contrasts or distinguishes between determinism and causality. What causality means is that you have to assume that everything is caused by something else. And the reason for this is that, yeah, to assume that something is uncaused is unscientific. It means that you're not trying to understand it. You're not looking for if you say that something is just random, it means you're not looking for an explanation for it. So you have to assume that everything is caused by something. What distinguishes causal laws from deterministic laws, that they can describe qualitative as well as quantitative change. So it's not just deterministic laws describing how the atoms move around, but yeah, there can be causal laws which describe how something, yeah, qualitatively new emerges from this level. Yeah, but if you assume that everything is caused by something else, why is this not deterministic? So I want to briefly go back to the previous definition of determinism, which was that all natural processes can be fully described through an initial state and a set of laws of nature. And for a given initial state, these laws of nature always give a unique future evolution. Or yeah, the laws describe a unique future evolution. Now, if you assume that there's this infinite number of levels of nature, then it's never going to be possible, or it's fundamentally impossible to have such a full description of the initial state of a system. It not only is this in principle impossible, but it's even impossible in practice. There is no full account of the initial state of any system, because it's just infinitely complex. And therefore, Bohm writes, so still in these letters to his female friends in the US, that it does not hold that the future is already contained logically in the present. because of this infinite complexity, there can always something new can emerge from the lower levels. And for this reason, the future is really open. Yeah. So that's what we find in his correspondence in this period. And these ideas then also soon emerged in his published work. So there's this paper from 1954 titled Model of the Causal Interpretation of Quantum Theory in Terms of a Fluid with Irregular Fluctuations. Oh, sorry. Which basically the aim of this paper is to explain a technical issue within his interpretation of quantum mechanics. Namely, it has to be explained somehow that the probability density for the configuration of a system is such that it's in accordance with the Bohm rule. And according to Bohm, this can be explained through assuming that there are random fluctuations at a lower level, so at the sub-quantum level. And he thinks that this assumption makes total sense, because there are always in any fluid or field, or in any physically real fluid or field, there are always some fluctuations. It's never possible to describe its evolution, or there's never a fixed set of laws describing its evolution. There are just always random fluctuations. Then in 1957, there's this book, Causality and Chance in Modern Physics, where he basically works out this idea of the infinite levels of nature. And here he argues that the assumption of strict determinism and the assumption of fundamental chance are equally unsupported. If there is determinism at a certain level, there may always be underlying chance. If there is something happens to be taking place by chance, there may always be underlying determinism, and basically nothing can ever be taken to be fundamental. And here he also argues that nature is inexhaustibly rich and complex. As science progresses, we can describe deeper levels of reality, but we should never assume that we have reached a fundamental level. So yeah, again, this unlimited complexity is the central point here. Now we jump forward in time to 1993. There's to the book The Undivided Universe by Bohm and Hiley. Here, in the introduction, we read that the question of determinism is therefore a secondary one, while the primary question is whether we can have an adequate conception of the reality of a quantum system, be this causal, or be this stochastic, or be it of any other nature. And later on, they write that ultimately our overall worldview is neither absolutely deterministic nor absolutely indeterministic. Yeah, so I think this is basically still the same view. Neither determinism nor chance can be taken to be fundamental. Now, it has been argued before, in particular by Oliver Frère, who is otherwise a great Bohm scholar, that Bohm was committed to determinism for at least a period in the early 1950s, and that this is connected to his commitment to Marxism also in this period. And Frère argues that at some point during the 1950s, Bohm abandoned determinism, and that this can probably be explained through his break with Marxism, through his disillusionment with Marxism in this period. And yeah, this may make sense because Marxism is somehow very often associated with determinism. Like in Marxism, there's these big laws according to which society develops, and yeah, the common image is that this is all strictly deterministic. But that's not necessarily the case. And in fact, Bohm's idea of this infinite number of levels of nature is in fact deeply embedded in Marxist philosophy. And in particular, Friedrich Engels, in the dialectical materialism of Friedrich Engels, there's exactly this idea of unlimited complexity of nature and of this and this idea of levels of nature. And this is a text that Bohm knew extremely well, or he was extremely familiar with Friedrich Engels' work on dialectical materialism. Apparently, when he moved to Brazil, he obtained a copy of Engels' Dialectics of Nature in Portuguese and learned that, used that to learn Portuguese. I think this Marxist philosophy is absolutely central to Bohm's idea in this, to Bohm's ideas in this period. But I would rather say that Bohm's deep interest in Marxist philosophy actually helped him to develop an account of causality which was not deterministic. Exactly, his interest in Marxism and in dialectical materialism helped him to overcome determinism, so to say. And yeah, this idea that Marxist philosophy is less deterministic than people often tend to think is also supported by the fact that there were a bunch of other physicists who argued against determinism from a dialectical materialist point of view. And here are 3 examples of 20th century physicists who were explicit Marxists and argued against the determinism from a Marxist point of view. And interestingly, the first 2 here, Leon Rosenfeld and Vladimir Fock, actually argued against Bohm's interpretation of quantum mechanics because they thought, like most people, they interpreted Bohm as someone who wanted to restore classical determinism, and they were very much opposed to this because they thought that they were very much opposed to determinism. So they actually argued against Bohm as well, against David Bohm's interpretation of quantum mechanics from a dialectical materialist point of view. So this idea that Marxism is somehow connected to determinism and that David Bohm's commitment or interest in Marxism is connected to his commitment to determinism, I think is just completely wrong. Good. So to conclude, was Bohm actually a determinist? Well, I do think it's true that Bohm did not accept pure chance. And this is also really something that he objected to in the standard interpretation of quantum mechanics. If you say that something is just taking place by chance, it means that you are not further investigating it, that you're not asking any further question. And this is something that Bohm found very problematic. However, he did not think that absolute determinism was justified either. He argued that basically to assume either absolute determinism or pure chance is both equally unjustified. You should always assume that things are more complicated, and you should always assume that there's still some underlying complexity. If something seems to be deterministic, there will be, if you dive deeper into it, you will find chance and randomness. If something seems to be taking place by chance, it's always possible to find to dive deeper into it and find some determining conditions after all. So yeah, he's really neither a determinist nor an indeterminist. But basically argues that both positions are equally unfounded. And yeah, his actual objections to standard quantum mechanics were different. His objections are mostly that it puts a limit to what we can understand. Quantum physicists basically say at some point that you cannot ask any further questions, and that there is a limit to understanding. This is what Bohm objected to. And yeah, although there's certainly some development in his thought, but I am mostly impressed by the fact that his views actually remain remarkably constant over time. That all his main philosophical commitments to complexity, to non-locality, the interconnectedness of everything. That's all of this can be found in his work from the very beginning. So thereby I come to the final part of the talk, the role of determinism in debates about quantum mechanics. So I will first say something about the reception of Bohm's interpretation of quantum mechanics. And this interpretation has very often been criticized for being conservative or even reactionary. Basically, everyone understood Bohm to want to go back to the determinism of classical physics. And yeah, this is something that he was explicitly criticized for. I've picked some examples here. Pauli arguing that the efforts of Bohm, as well as Schrödinger and Einstein, so other main opponents of standard theory of quantum mechanics, are reactionary attempts to go back to classical physics. Heisenberg writes that Bohm and also the other critics of Copenhagen interpretation are trying to push new ideas into an old system of concepts belonging to an earlier philosophy. And Leon Roosevelt, who we already saw briefly before as one of the Marxist critics of Bohm, argued that Bohm's theory of quantum mechanics is motivated by a metaphysical prejudice of determinism. So it was really received or criticized as being conservative and reactionary and wanting to go back to classical physics. And the interesting idea is that something similar can be said about Erwin Schrödinger and Albert Einstein. In this period, so the 1950s, there was a standard interpretation of quantum mechanics, which is known as the Copenhagen interpretation, and its most well-known critics in this period are Albert Einstein, Erwin Schrödinger, and David Bohm. And all three of them, as we see in these quotes, or as we see in the example of Pauli, all three of them were basically criticized for being conservative and reactionary. Now, if we look at the example of Schrödinger, so he was also critical of standard interpretation of quantum mechanics. However, interestingly, in the early 20th century, before the theory of quantum mechanics was actually developed in its current form, so in 1910s, Erwin Schrödinger actually argued against determinism. He actually argued that the assumption of determinism is unfounded by it has turned out with the development of statistical mechanics that laws of nature can also be statistical. Why couldn't it be the case that this holds for all our laws of nature? Maybe atoms just move around randomly. Who is to say, yeah, who says that this cannot be the case? So apparently before the introduction of quantum mechanics, he argued against determinism. Then quantum mechanics was developed and Schrödinger objected to it and argued that this theory has to be wrong. And somehow this led to the idea that he somehow changed his mind about determinism, that he turned out to be attached to determinism or causality after all. If you look what is Schrödinger actually objecting to, it's not the indeterminism of quantum mechanics. It's more general. He has more general objections to the weirdness of quantum mechanics. Specifically, Schrödinger objected to the idea of quantum jumps, to the collapse of the wave function when you make a measurement. Of course, the Schrödinger cat example, he didn't argue, look how cool it is that a cat can be dead and alive. He was arguing that there's really something wrong here. So yeah, somehow because he was critical of the standard theory of quantum mechanics, people thought he is actually attached to determinism, but yeah, his actual concerns with quantum mechanics were different. And the same can be argued for Einstein as well, who is very famous quote is that God does not play dice. Apparently this was his problem with quantum mechanics, that there's this, he cannot accept this randomness. Yeah, but also for Einstein, it has been argued that his main concern was with realism, which for him means the idea that there is an observer-independent reality, that there are spatially separate systems possessing separate physical states, and the idea that there is no action at a distance. This were the things that Einstein was really concerned with. These are the assumptions that he didn't want to give up. And they are different from Bohm's assumptions, definitely. So he had quite different, his views on quantum mechanics are quite different from those of Bohm. But yeah, what they have in common is that they were criticized mainly for wanting to restore determinism, but their actual concerns went deeper. Yeah, so to conclude, yeah, there has been a tendency to interpret all opposition to the standard interpretation of quantum mechanics as an attachment to classical determinism, and thereby as conservative and dogmatic. But in any case, for Bohm as well as for Schrödinger and Einstein, it holds that what they were primarily aiming at was an understanding of quantum processes. And this was what they thought lacked in the standard account of quantum mechanics. It doesn't enable an understanding of what's actually going on. And this aim at an understanding of quantum processes is somehow, and for all three of them in different ways, connected to some form of causality, but it's not necessarily determinist. Yeah, so that was my talk. Thank you very much. Are there any
thank you.
questions?
Thank you. Thank you so much, Marij. That was a beautiful presentation. Pavel, would you like to come in?
Okay. Yes, thank you very, very much. I think that was actually, let me take this off. me take these ones off. So can you hear me?
Yes.
Yes, yes. No, it's very nice, and I think it's very interesting this this overview. And there was one thing you were puzzled about, the fact that he published 52 this interpretation, deterministic interpretation, and then he was writing to these three women that about this like trying to avoid the determinists. But it might be a tiny point, but he probably worked on the interpretation in 1951.
Yeah, right.
When he actually developed it, and then he went to Brazil, and then he started writing those letters.
Yeah, that's true, right. Yeah,
Maybe
so
he
he might
also,
still have been a determinist for like a year or so.
or else he hadn't thought about it in the sense that it was just that maybe he then realized that people are going to object to this feature, and then he started thinking about, well, what am I going to do about it?
Yeah.
I also think a little bit that there's sometimes I don't know exactly from where, but sometimes I got the feeling that Bohm blamed Einstein for the deterministic part. Because they had discussions when Bohm had published the 51 book.
Mm-hmm.
And they had those Einstein actually, I think Bohm himself was going to get in touch with Einstein, but then Einstein himself actually invited Bohm to have discussions. And so there in those discussions, I think it may still have been Einstein who wanted to have this deterministic extension, whereas Bohm says he himself wanted to more have a notion of reality. So they kind of, it's almost like nobody wants to take the blame
Mm-hmm.
for because then we say about Einstein that Einstein also, he was more interested in reality rather than determinism. But
yeah,
but it's sort of a, but of course the question is then that when one reads the Bohm's those 52 papers, that how much does he there emphasize determinism?
yeah, right.
These are just comments. I mean, but it could be the case that he very soon starts thinking about it. And I guess the other thing is in the 52 Bohm theory, you still have to explain where do you get this, why does the Bohm rule work? When you do an experiment, why does it all look statistical? If it's a determinist theory, why does it look statistical? Where, well, you have to have the statistical distribution in the beginning, and the dynamics of the theory just mechanically takes that distribution from place A to place B. So it's there when the electrons, the electrons start, and it will be there in the screen when the electrons arrive. So you will have this sort of so I guess this worried Bohm, that how does he explain, why does the Bohm rule, the Bohmian dynamics doesn't as such create the Bohm, it doesn't contain the Bohm rule as such. So he has to argue why, if I take any set of particles, I do my two-slit experiments, why do I get this statistics there?
Yeah.
He says something about that he wrote himself this, as you probably know, he wrote this short paper 1953 in Physical Review, where it's a very short one where he's trying to explain why the Bohm rule holds.
Yeah.
But then 54 in the paper you show with Vigier, then they, like Bohm felt, they say that what Bohm did in 53 wasn't good enough, and now they're trying to do the thing that you described, where you have this
random
fluctuations and all that. But it's an extremely interesting question, and I think what you really brilliantly brought out was the way the dialectical materialism has this rich structure that, if you like, Bohm inherited. I really like the way you put it. I mean, because it's always a little bit of a puzzle. How are we going to sort of deal with it then?
Yeah.
So
Yeah,
that's,
I think,
I just thought that was very interesting.
sorry, the connection is, I missed the last thing you said because the connection was.
Oh, I say, no, I just said about that the dialectical materialism, which is, it's very interesting in the sense whether that's something that Bohm uses.
No, yeah, I think absolutely, yeah. The dialectical materialism is very important for Bohm. There is both the idea of unlimited complexity, this idea of levels of nature. He also somehow argues that there is a dialectical relation between determinism and chance. Yeah, indeed. And there's somehow always this idea that Marxism is very dogmatic and determinist and mechanist and materialist. But it's way more complex in any case, Friedrich Engels' dialectical materialism. Yeah, thank you very much for your comments. Yeah, I think it's right that, or you are completely correct that Bohm already wrote this paper with his interpretation of quantum mechanics in 1951. So yeah, he might have been committed to determinism at this period, but first it's still only a very short period, and second, it cannot have been a very strong commitment because, yeah, shortly before and shortly after, he argues basically against determinism, and in these 1952 papers, he doesn't emphasize it very much. He does say, well, we have to look how things are determined, but if you look at his formulations of what his main aim is with these papers, then he really doesn't emphasize determinism so much. So if he was ever committed to determinism, it was only a weak commitment.
One interesting thing that I think I remember from reading when I was reading the David Peat's biography, then if I remember correctly, then it seems that Bohm there, when he went to Berkeley, then he was reluctant to accept these sort of some features of quantum mechanics, and he had this discussion with somebody, I forget the name, who it was, in Berkeley, and they were arguing, and then the other person more classical explanations. So that I don't know if it was commitment or determinism, but it was certainly that perhaps he initially had difficulties of accepting quantum weirdness, and he was really, trying to always to find a, if you like, rational explanation. And so maybe that was there one motivating him, why even when he wrote this textbook in 1951, which a lot of people think was a great textbook, he himself felt that he was still not satisfied.
Yeah, true, yeah.
And so that may be that he had that in him, that he somehow wanted to find a more rational, it's not necessarily that it's not maybe only the determinist, but it's some kind of rational explanation of quantum, something that makes sense.
Yeah, yes.
I think that he had that strongly in him. And of course, maybe now we could ask, well, what's the connection of determinists? That I think that you had that in your early slides, that somehow determinism helps us to make sense of what happens, right?
Yeah, yes.
And the thing about intelligibility, which also Bill Seeger talked about, and Maria-Lisa Kakkuri-Knuttila will talk about tomorrow, this whole idea of Bohm's motivation of trying to make sense. But of course, there the interesting question is, well, what does it mean that something, when we make sense of things, that it's like they were accusing Bohm, like you were saying that, Heisenberg was saying that he was trying to put these new ideas into old bottle, so to speak.
Yeah, right.
And so there's always that sort of thing that. And finally, question is, I was just curious. I know you have written also about Bohm's later work, but one interesting thing is, of course, what happens after the 50s. That to what extent does Bohm there give up the attempt to make sense of things in a particular way, opening up to this new ideas of order and
Yeah.
whether there's a continuity there or whether there's a change. I don't know. I'm just putting some ideas there.
Yeah.
I don't know. What do you think about these? So.
Yeah, right. So yeah, I actually think that there's a lot of continuity. Even as you said, even before he wrote the 1951 book, he already had concerns about quantum mechanics. Yeah, then he writes this book, which is basically Introduction to Standard Quantum Mechanics, and he develops his own interpretation, and he abandons it and starts looking for other theories of quantum mechanics. So there's big changes in the physics he is actually working on, but I think throughout this period his philosophical commitments remained remarkably constant. And indeed he I think determinism is often connected with understanding, and this is something that is important for Bohm. But with yeah, because as I mentioned, he does have this commitment to causality, that everything has to have a cause, or you have to assume that everything has a cause somehow, and he objects to the acceptance of pure chance in quantum mechanics. However, I think central to the idea of determinism is that there is in principle that this possibility of a complete description, of a full account of quantum processes, and that is exactly the thing that he objects to, because he has this idea of this unlimited complexity. And I think all of this idea of complexity, this idea of it has to be possible to always ask further questions and to dive deeper into something, and to this emphasis on understanding, that's all there throughout all these changes in his views of quantum mechanics.
I have some couple of comments before we open up. Is this one? Of course, the one puzzling thing is about when we think about things like determinism and indeterminism, when we apply that to the whole universe. And I recall that in the when the book Causality and Chance was republished in 1984 by Routledge, and Bohm there write a new preface to that. And there he then says that I think he again talks about this question of determinism, and maybe saying that we have open systems, so the determinism is never very strict, because if the system is open, there was always possible that something new could come and change it. But then he says that, but when you think of the universe as a whole, then he says that it's self-determined. Now, what does that mean? And does that still put the money to determinism? If you accept, if you're saying that the universe is self-determined.
That's something that I have to look at.
Yeah, I know this.
Yeah.
Or else whether it's a kind of creativity that he has in mind, that if self-determination can be in some sense a creative process, because of course he had this, and interestingly also he writes so much, like this is what that's an interesting book that you refer to, these letters to three women. There's recently came out his letters with Geoffrey Boom. And of course with Charles Biederman, there are only some of those letters have been published. So of course he talks a lot in those letters about this nature as some sort of creative process or creative process structure. And of course this idea of creativity is also, how do we connect creativity with either determinism or indeterminism? in the sense. It's a bit the same as with free will. It's a big problem in philosophy. How do we, you know, if we say everything is deterministic, then there's a tension with the idea of free will. If we bring in randomness, it doesn't help either. So what do we do? I think I think in philosophy we still haven't solved that problem. And I think Bohm may even there has some of these ideas that this sort of what he was trying to develop there with this rich notion, but there's much there to still to try to figure out that. But I mean, I would definitely agree with, I think what you were saying is very reasonable about this, that it would be a mistake to call Bohm a determinist. And it's of course it's an interesting question whether there was superior when he was, what, you know, he of course he got, I mean, we can tell from the correspondence that he got very excited about his 52 papers. He says, like, how come I was the one to see this? So he felt like he was really lucky. He was really, this was like a gift from God, that he was the one to get the theory, and maybe, you know, that was a deterministic theory. He was really excited about it. So why not? I mean, but then of course, then you start thinking about it, and then you realize that it doesn't fit as such. It just assuming that the world is exactly like what the 52 theory says, that might even go against the dialectical materialism.
Yeah, but
dear to him,
still,
or somehow which he felt.
Yeah, although this paper would still be a big step. It enables an understanding of quantum mechanics. It shows that you can go further, and then it can be supplemented with random fluctuations.
Yeah. And that's an interesting, I mean, there is, if of course these things are difficult, and I know them all only up to a point, but there is this thing that later on Nelson also tried to work with this stochastic interpretation, and then Bohm and Hiley published a paper in 1989 about the stochastic. So in a way, going a bit back, looking at the Bohm-Vizier 54, but then doing something new. And one interesting thing there is that even in this stochastic theories, you have this non-locality. And even this guy Nelson accepted it. That I think for a long time Nelson felt that the whole point of having a stochastic interpretation is that you could also avoid non-locality. So that sort of comes into it. And but then it seems that this is something that, and of course Bohm doesn't emphasize non-locality so much in the 52 papers, but much more in the later work. And now we could ask about, well, what is non-locality? Is that the kind of necessity? It's not necessarily causal. I mean, Bohm himself in the book Wholeness and the Implicate Order, he says that non-locality is a non-causal relationship. So he thinks that causality maybe refers to, maybe a bit like theory of relativity, that there has to be somehow A influencing B through some process that takes time. Whereas with non-locality, it's not causal in the usual sense. Yeah, but what is it then again? It still seems like necessity in the sense that if one way of understanding non-locality, you do something to particle A and particle B kind of instantaneously is affected.
Yeah.
And that's another thing that I think one would one of those questions to think about. I mean, I have no answer to this, but it's just this whole picture that not only was the Bohm theory deterministic, but it also had this non-locality in it.
Yeah.
And the question is, what does that mean in terms of causality, or determinism or indeterminism?
Yeah.
Non-locality, it certainly has. It's certainly not only in determinism. It's more like something, necessity, right?
Yeah, I think Yeah, with the question of non-locality, is that also non-causality? I think that's a bit tricky because causality can mean so many different things. And in the context of relativity theory, generally, causality is exactly defined as there being no action at a distance, or
Right.
so if you're speaking in this context, then indeed you can say that non-locality is a violation of causality, but maybe then you're using only one particular meaning of causality. I think with this non-locality, I think that's also again something that's even there already in the 1951 book, the quantum theory, also already emphasizes the interconnectedness of everything.
Yeah, he does the EPR paradox in a new way in the 51 book in terms of spin, and
right, yes, yeah.
Quite an interesting discussion of the whole.
So he is quite, heavy metaphysics, like very heavy metaphysical assumption of complexity and non-locality and interconnectedness of everything. And you can debate how plausible this all is. It's quite, heavy metaphysics. But I think, as I said, it's there all throughout.
Yeah. Anyway, there seem to be a number of other questions, so perhaps we can move on, and Elinor, you can maybe select the questions.
Absolutely. Thank you so much, Pavel, for coming in. I am now going to pass it over to Gary. He was the first to have his hand up, but I'll just pass in my computer a moment.
I'm sitting next to Eleanor. I think that this is a false dichotomy between pure determinism and pure indeterminism. And that what is really important is pragmatic reality, pragmatic realism. And it comes out, I think, most clearly in the issue of non-locality, right? Where Einstein's very concerned because there's no way to explain non-locality through causal mechanism. And so this undermines the whole idea that comes out of classical physics, that everything is determined through causal mechanism. And I think, that one of the interesting things about Bohm is that Bohm realized that it's neither one nor the other, it's both, right? It's very much dependent on context, because we're talking about complex systems, and complex systems are impredicative. You cannot fully determine them. And that's been shown actually in relational biology by Robert Rosen, that if you have a closed causal loop operating on a continuum, you cannot fully predict what's going to happen. There will be rules, there will be laws, but the laws are not fully predictive. There's impredicativity that's inherent in the math. So the person who I think was most influential, and the other thing is, let's recognize that non-locality is very, very real. It's been shown to be the case in multiple experiments. So you can't debunk it in some way by saying non-locality is some type of an illusion. John Bell was the one who actually showed that non-locality was likely to be very real. And he said some very interesting things, right? He said, nobody can understand this theory until he's willing to think of the psi of the wave equation as a real objective field, not as a probability amplitude, right? Which was the standard interpretation, was to look at the wave equation as being a probability. And that's, I think, what a lot of people had trouble with, is this idea of interpreting, through Bohr's direction, restricting the questions you can ask, and basically saying that you can only talk about probabilities. You cannot talk about certainties. The other thing that is directly from John Bell is the following quote: conventional formulations of quantum theory, which he's referring to the Bohr interpretation, and of quantum field theory in particular, are quantum field theory in particular, are unprofessionally vague and ambiguous. Professional theoretical physicists ought to be able to do better. Bohm has shown us a way. That's a direct quote from John Bell.
Mm-hmm.
And I think, I think what we need to, recognize is that this dichotomization of either the world is entirely predictable and operates as a causal mechanism, which we've been fooled into thinking is true by classical physics, is just, first of all, it's not supportable when, that's the message of quantum physics, is that classical mechanism doesn't work under certain conditions. And secondly, that pure indeterminism, that everything happens totally by chance, is also not supportable, right? So that what you need is some type of a mediation, a way of mediating between determinism and indeterminism. And I think that's what Bohm was after in terms of the relationship between the implicate and the explicit order.
Mm-hmm.
Right? That the implicate order is operating on a continuum and is, the quantum world. But what we observe in the explicit order appears to be deterministic and causal, but it's not, right? Because it's an illusion that is not being fully conveyed. So I guess the question I would have for you is, how you would see Bohm as a realist, right? As a pragmatic realist, that he was really trying to describe how reality truly is, and was not committed either to determinism or to indeterminism, but to some type of a mediated combination of the two.
Yeah.
And just to add one thing, this is exactly how Charles Sanders Peirce's metaphysics works, his scientific metaphysics, that you have one level, which is pure chance, you have another level, which is pure causation, and then you have a third level, which is the mediation between those two levels. And that's the reality. The reality is that there is a mediation going on between pure indeterminism and chance, and pure determinism and lawful causality.
Yeah. Mm-hmm.
That's the question.
Yeah, thanks. So that was a lot. Let me see what I can react to. Yeah, I think that's right, that Bohm is after some middle way between determinism and indeterminism, which I think it's quite interesting. And what I also mentioned in the beginning is that what we can also learn from Bohm's interpretation of quantum mechanics is just the possibility of having a deterministic account of quantum mechanics. Generally, that there are all these different interpretations of quantum mechanics, which basically give all completely different accounts of what nature is actually like, shows us that quantum mechanics really doesn't tell us so much about what nature is actually like. Quantum mechanics generally cannot tell us whether nature is deterministic or indeterministic. So that's what I personally like, this point of, we should be a bit modest in drawing conclusions from physical theories. And I think Bohm's views are not exactly modest. He has a very clear, detailed metaphysical picture. But also here there's the idea that both determinism and indeterminism are in the end unfounded. So there is some modesty here as well. Whatever theory you come up with, you can always go to a deeper level where this theory breaks down again. So you can never draw any absolute conclusions, basically. About the connection with pragmatic realism, yeah, that's quite interesting. I would like to look into that more.
Okay, thank
So
you.
I think if I comment also, one thing that is interesting, of course, is how Bohm's ideas about kind of more general ideas about reality and science evolved, and because in the Causality and Chance book, for example, he has the view that scientific theories could even almost like approach absolute truth at the given domain. So this is the idea of truth likeness, and I was when I was interacting with him, this was in the late 80s and early 90s, and I was doing my PhD in philosophy, and I was doing these things, and he was almost embarrassed when I kind of reminded him of this view, because in the 60s his ideas changed. Of course he read Thomas Kuhn. I mean, he was close to Feyerabend. I think Bohm influenced Feyerabend, but maybe it was also the other way around, because Feyerabend is, of course, very radical in philosophy of science, and Marij has written about Feyerabend as well. But they knew each other, and then of course Bohm was interacting quite a lot with Karl Popper. Popper would invite Bohm to his house. They had many discussions, and Popper had this idea of course falsification. The idea we actually never know that our theories are true. We only know that they are not yet false if there hasn't a test. But I think also Bohm was quite excited about Thomas Kuhn. He wrote a review of Kuhn's Structure of Scientific Revolutions, and in the book by Bohm and Pete, Science, Order, and Creativity, they don't talk about paradigms, but they talk about this hidden infrastructure of ideas. So they really think that even in science, our trouble is always that we have these hidden structures kind of almost unconsciously affecting the way we think and way we do our experiments and all that, and we we can't have the dialogue because we're not aware of all these things, and so but it's interesting the way Bohm's overall ideas about the theories and reality kind of developed, that whether because interesting what Marij has suggested, that Bohm was actually quite stable in his views, and it's in a way it's maybe true, but he got excited about these other developments, and they probably influenced him, and I might mention just as a little thing to finish, that in the Undivided Universe with Hailey, they have this maybe chapter 13 when they talk about their general worldview, and which I think, Marij, you had taken also something from that, some quotation from that part, and then this is something that I actually mentioned when we started out here a few weeks ago, that when they were writing the book, I was also then visiting at Birkbeck College, and I was reading some of the drafts. And in that chapter, Bohm was saying that everything is appearance. If you remember that, they talk about this appearance and essence. So in a way that the table appears elliptical, but then actually it can be circular. So appearance is elliptical, but then when you look at it, you realize that it's circular. But the same thing. But then we say, well, it's not the table. The table is an appearance. Actually, the essence is the atoms. But then you can go deeper where every essence becomes an appearance. And in the end, so everything is appearance. So then I asked Bohm, so if everything is appearance, what's the point of making an ontological interpretation of quantum mechanics? Because I thought the point of ontology was to get to the essence rather than appearance. Because appearance is still, it sounds epistemic, it's, you know, rather than ontological, or at least it's something to do with us because it's appearance to us. And then he went home and he came back the next day, and then he had he then wanted to add something to the text about saying that each theory reflects reality at its own level. So he was going away back to this idea of still a kind of realist picture. Again, perhaps suggesting what Marij is correct, that he, in his, in some ways, his views did remain stable, and so so he but then he said something like that they are those, but then all phenomena, they depend on context and deeper levels. So it's not as if a theory is describing some part of the world, it's not absolute in the sense because then it's still, there are still these other things that are, if you like, deeper and make it more limited. But
yeah,
but it's, sorry, but just to go to this whole, what Gary raised, the notion of pragmatic realist, and it's an interesting that Bohm has many pragmatist ideas. If you read his writings, he talks about knowledge as a way of, as an activity, and but then there's also seems to be this more realist idea that theories do describe, they're not only pragmatic tools to describe reality, but not in absolute sense. But anyway, what do you think about this?
Yeah, I think a lot of, I think the issue of realism is equally tricky as the issue of causality, because there's the same issue, just like causality, realism can mean many different things. And so I'm not sure whether in the 1957 book, Bohm really argues that we can obtain absolutely true knowledge of each level.
At each level, but I think he says that he thinks in principle that if you take a limited domain, that it could approach. Maybe I can send you the reference to that. But I recall that he there uses this. It's in the final chapter.
Mm-hmm.
He there uses this idea that, but then he says with the totality, there's no way we could have a complete description.
Yeah.
But he does assume that it's almost like you're assuming that the world is such that if you take a given level, you could pretty much get an accurate description.
So one thing is whether you can obtain reliable knowledge of nature, and here I think Bohm is definitely thinks that we can obtain reliable knowledge. If you can, for example, classical mechanics still works great even after the quantum revolution and will always give us very accurate predictions. So yeah, at a certain level you can obtain very reliable knowledge. Is that another question is, does science describe reality as it actually is, independent of us? And here some interesting things comes in with measurement, because you would say that in both theory of quantum mechanics, the measurement problem has been solved. Measurement is totally non-mysterious. You just measure properties that are already there in the quantum system, independently of the measurement. But that's also not generally the case, because for position, it holds that if you make a position measurement, in Bohm's interpretation of quantum mechanics, you measure the position that is already there before. But if you measure the momentum. That's not the case. So actually all other variables except for position are contextual. So what you will measure depends on the entire setting, including the measurement instrument. So there's not the mysteriousness of measurement that you look at the world and the world changes by looking at it, but still you influence the world by measuring it. And that's especially in his later work, Bohm emphasizes this for this reason. Nature or science does generally not describe nature as it is really is independently of us. And this is where I would make the connection with pragmatic realism. We act in the world and we obtain knowledge through acting and seeing how the world responds to our actions, so to say. So here, so the pragmatic realism in connection to causality and determinism, I have to look into it, but this views on realism, I think that this can really be understood in a pragmatic realist way. And that means science can give us very reliable knowledge. At the same time, science does not describe the world as it really is independently of us.
Yeah.
And does science give us true knowledge? Yeah, that's also always tricky, of course, I think. So I think there's I think I agree with you that there's definitely a shift here in his views, and he emphasizes more these possibly non-realistic elements or aspects, but I still would see it more as a shift than as really a break with his previous ideas.
Right.
Shall I bring in somebody else now?
Yeah, sure. I just put in the chat this little thing from the causality and chance.
Oh, thank you.
Where he, I don't have the page number here, but it's in the final chapter, and he says that that if we take into account error,
you're right.
then we are approaching closer and closer to an absolute truth, and more or less as we are able to come closer and closer to this using a mathematical metaphor. So this is still optimistic, and I think later on, I think when he writes he writes it in 65 in the special theory of relativity, he would deny this. So I don't think he. So in that sense, his views probably changed a little bit. That he had in the 50s, he was in that sense still maybe a little bit more, I don't know, optimistic or realist, but
I think you're right in that this formulation that we get closer to absolute truth, I wouldn't think that he would still say that in the 1980s.
It's using quite strong language, and
Govert, would you like to come in?
Oh, absolutely, yes. Thank you so much for the wonderful presentation. It was fascinating, including the discussion. Just quick question. I assume you're Dutch.
Right, yes.
Which I am too. Okay, having established that, good. I'm coming kind of from a philosophical level, although I would love to get into, let's say, the development of Bohm's, let's say, political views in connection with Marxism and determinism, or get into this, and I'm just only digging into that thing where phenomenology and quantum mechanics are combining in something called cubism. I don't know if you've heard of that. That would be a very fascinating thing, because that's a philosophy that lets go of making things intelligible, what's happening at the quantum level. You just look at the results and forget about imagining or making it intelligible. But anyway, so I'm coming from a philosophical level. I'm actually calling in from India, where I'm on a project to do kind of a phenomenology of the teachings of Krishnamurti.
Mm-hmm.
And so what I'm interested is Krishnamurti picking up some of his idioms, some of his ideas, sometimes even from philosophical sources. Like in the early 20s, he read Nietzsche's Thus Spake Zarathustra, and somebody found that he picked up some idioms from there. Connecting it with Bohm, of course, I'm interested in their interaction. Did they get ideas of each other? Did they pick up idioms of each other? And initially, because this talk is about determinism and Bohm's concept of determinism, I first had picked up the idea, I don't know from where, that, oh yeah, okay, Bohm is a determinist. So I thought, well, that goes very nicely with Krishnamurti's idea of so-called choiceless awareness. You just cannot do anything, you just observe, and that might have a transformative effect then on your life if your observation becomes very intense. And you come to the realization that the observer is the observed, which was, of course, the bridge by which Bohm found Krishnamurti, because, it's one system, the observed and the observed in quantum mechanics, maybe even in any system that you indicated. We have some influence on the system that we're observing. So we have to see it as a holistic system with two parts. So my question is, how far have you yourself dug into possible exchanges of idioms and ideas between Krishnamurti and Bohm? And how far the idea of determinism and free will were possible subjects there? I myself have seen some of their discussions. I've read some of Bohm's books. Of course, I'm very familiar with Krishnamurti. But in this context, I'd like to bring it a little bit to an existential level with Bohm. Also, his own ideas about free will or non-free will, Anyway, that's my question. I very much appreciate your work, very much so.
Thank you. Yeah, thanks for the question. That's really interesting questions that I unfortunately cannot answer at all. I have not looked into interactions between Bohm and Krishnamurti. And the question about Bohm's ideas about free will, that's also something that's already came up before. Would also be really interesting too, but I don't know anything about Bohm's
or maybe then his further connection with Marxism. Did he dump that? Because it's quite a jump going from dialectical materialism to this kind of spiritual New Age philosophy of Krishnamurti.
Right. Yeah, indeed, it's an interesting development. Yeah, he did. Bohm did get disillusioned with Marxism. It was very important for him for a while, but like many people, at some point he got disillusioned with Marxism. And nevertheless, I think some of these ideas from the dialectic materialism in some way lived on in his work. And how does this fit together with this more spiritual stuff? Yeah, it seems completely different. But on the one hand, there's, as I said, people tend to think that Marxism, dialectical materialism, is very materialistic and mechanistic and deterministic. Well, it can, as many things, there are many different forms of dialectic or materialism, many different views, and it can also be much freer. And of course, it also led Bohm to Hegel and to an serious interest in Hegel, which can go in
so as a
very
last
different
little
direction as
question,
well.
So how much philosophy did he read then? Okay, he read Marx, he read Hegel. What else do you know that he might have been exposed to?
Whitehead. Didn't
Okay,
he
process.
had Whitehead as well. Yeah, process also fits. Yeah.
Thank you. Thank you.
Yeah, well, enough to explore. Thank you.
Thank you so much.
I could maybe comment a little bit on the on this Bohm Krishnamurti mutual influence in the sense that of course I think some people who really have listened to a lot of Krishnamurti can tell there was a change, that there was an influence from Bohm, that it, you know, those discussions had an influence on Krishnamurti. But of course for Bohm it opened up an entirely new theme. I mean, Krishnamurti didn't start studying physics or anything like that. He was doing what he was doing before, but for Bohm, of course, it was change. It opened up an entirely new exploration, and he wrote a lot about that. And I guess there were interviews of Bohm, which Maurice Wilkins did, where they discuss about this how, for example, what's the difference between Krishnamurti and Marx? Like what maybe Marx had some ideas about false consciousness and things like that, but then, you know, Krishnamurti talked much more about changing consciousness and things like that. So I think definitely it did influence a lot of what Bohm did, and sort of and you could look at it also in the sense of that. Of course, Marxism is about change. It's about changing society, and sort of, and there's a faith that, of course, you know, the faith. You know, one way of looking at Marxism to say that this change will happen automatically through the laws of dialectics. And we might just speed things up a little bit by acting ourselves, but it's more like it's a belief that there is this dialectic in not only nature but also in society. And with Krishnamurti, there's the change is something that comes through whatever meditation or self-knowledge, or realizing that the observer is observed, or, you know, all those kind of things that they were talking about. But it's still maybe something that I think in the case of Krishnamurti, it's not optimistic in that sense. It requires a lot of work, and what you talked about, this choiceless awareness and things like that. But of course, then it's a very tricky thing, because when Krishnamurti died, he said that nobody has changed. He said at some point he said that if somebody understood what he had to say, David, but so then people, and even Bohm was asking the question, well, if nobody has changed except for Krishnamurti, where's the problem? Is the problem in us? You know, people trying to understand Krishnamurti, might there be a problem in Krishnamurti himself, or then in the communication? And I think Bohm was sort of I think he was kind of implying, I think toward the end of his life, he got a little bit skeptical about Krishnamurti. Not, I mean, of course, appreciating that it had great value, but I think he also got a bit more skeptical, and I think he felt that there was something missing. And I think that was one of the reasons why he went on to develop the dialogue method, and he felt that in a way, he went back to more Marxist approach, more collective, more social. Because Krishnamurti was very much about an individual person having a transformation, and then that would change the world. And I think Bohm went back to feeling, no, we must have a collective change in the dialogue process. It's useless to have one enlightened person if that person cannot communicate to others properly.
Yeah. Quick question. Did Bohm know about Vimala Thakar?
Probably
That
yes.
was,
I mean, yeah, probably yes, but I probably
because that's one of the crucial relationships that Krishnamurti had with someone who kind of, well, claimed that she had gone through the revolution of what Krishnamurti asked for, and it seems to be that he acknowledged that, and it certainly had an influence on my life to find out that there was at least one other person who arguably had gone through that revolution. But of course, then there was a problem with Krishnamurti because she brought out a little autobiography, because she was being depicted as, oh, she's just a female Krishnamurti. And then she was like, no, I have my own story to tell. And Krishnamurti was not very happy with how he was depicted in that book. So they had a little bit of a break there. But in that sense, arguably there is someone, and maybe there are more, that did it. And I wonder how that would, impact David Bohm, because he might have known about her and her background story. But you say you're not totally sure.
Well, I don't know. I think it's more the fact that even in that case where there allegedly was somebody who had understood, and even that became a kind of a bit of a mess. It's just another example how this focus on individual transformation, holier than thou, more enlightened than thou, instead of, it has some help, it helps us, but it also leads to endless chaos and endless problems and endless, sorry, I'm being too negative, too cynical, but I think it's in some sense, I think Bohm didn't, after a period, I don't think he appreciated this business of individual enlightened so much. Because I think it's a red herring. It's not actually helping us to change. It's not actually helping us to make a better society. Instead, we have a lot of people focusing on worrying about personality of Krishnamurti or other people, instead of actually finding out together, maybe none of us is enlightened, but is there something we can actually do to change things? So I think I think Bohm also found very difficult this whole setup but I must add, of course, he appreciated tremendously all the insights. But I think maybe he wanted to bring a bit of science into this, in some ways, a more charismatic and authoritarian system that you, I think, inevitably have with when you have this more guru-like structure. And I think he, at least toward the end of his life, he wanted to, I think his whole idea of dialogue was also trying to create something more perhaps democratic and egalitarian and more kind of collective and enlightened, and forget about the odd individual enlightened person. Not that,
but of course, Krishnamurti had this idea too, like, let's do this together. We are together here as friends talking. But then, mostly it became monologues instead of dialogues.
Well, yeah, and yes. But anyway, but let's have, if there are other questions. Sorry, Marij, I took this question, but
thank you. Because you can definitely answer this question much better than I can.
I'm familiar with the topic, so I used to talk with Bohm a lot about these things. So I just took the opportunity to share this, because in some ways it always comes up and people are concerned about these questions. And I think it's important to realize that sort of, although Bohm was extremely interested in Krishnamurti and he got a lot out of it, he also did have his own view about it and sort of in some ways try to navigate toward another approach, and not denying the value of what of the interactions, not at all that, but still trying to actually find a solution for us.
Maybe we can open it now up to Patricia. Would you like to come in?
Yeah, thank you. As others have said, I really appreciate your presentation, and it's enlightening and fascinating. I'm coming from the standpoint of an occupational therapist, and an educator. So I'm very grounded in real life, making things better. So some of this past discussion was a great segue to my question here. You've talked several times about different levels of nature, and as an OT, I have my own ideas about that, but I am lacking in the definitions of what you're talking about. So I wondered if you could describe those levels a little bit more, how you see them. And I wonder, in particular, two things: how they relate to non-locality, and if there might be different kinds of level systems.
So yeah, the idea of levels of nature is fundamentally that you can describe nature as at a certain level. There are the everyday objects, there's you and me, and if you zoom in, you see there are cells which have to be described on the level of biology. Then you get to, if you zoom in further, you'll get to atoms and etc., which have to be described on the level of physics. Yeah, so you just, at every level, you have different scientific theories and also different entities. How does this relate to non-locality? And can there be also different systems of levels? I think that goes in the direction of Bohm's later views on the implicit order, where maybe you don't have not just have different entities at every level, but even space and time may emerge from a lower level where there's no space and time, or may not be fundamental. And then if that's the case, then everything can also be connected in a non-local way. So this is more found in Bohm's later work. But fundamentally, I think this idea of levels of nature is just this basic idea of you zoom in and the world looks very differently, and there are different entities which you have to describe in different ways.
Thank you. In my field, we actually go the opposite direction and say that there's levels in terms of life systems, the human level and the family level and the community level, all the way up to global ecology. And then in my perspective, and I kind of came to this from reading some of Bohm's work, is that there are levels of development. So if you look at Piaget, we start with a very sensory motor kind of an experience, and then we start learning about social experience and how to participate there. And then our emotions come into play and we have to kind of resolve that. And then we move into school and, learning facts, and then expanding our cognitive abilities to looking at systems of things. And then you can get into the more metaphysical of the psyche and idealistic, all the way up to spiritual. So that's the kind of levels that I see. And I guess I'm wondering if those of you who have studied Bohm see that as consistent, or I guess consistent is the right word, with his ideas about levels and subtlety and tangible,
Sure.
different things. Does that make sense to you, or am I like off on some crazy tangent that doesn't make sense?
Yeah, sure. Well, so I think that these are two different kinds of levels. One are the skill levels, so you can zoom in or zoom out, family level, world level, level of cells, level of atoms. I don't think, or I don't recall Bohm speaking about the family level, but why not?
He didn't. That was mine.
Yeah, right. But yeah, no, why not within this framework? And then the other are developmental levels, and I think this light's really making things worse. Can be connected to the idea that there generally new things can emerge in the world. There's one objective Bohm has to determinism is that with the determinist picture, basically nothing new ever happens. And he thinks this is wrong, and generally new things can emerge also temporarily. Yeah, so that's at least quite consistent with the idea of there being developmental levels. Maybe also in society, if we connect it again to dialectical materialism, where there are these big laws of how science, of how society develops, but at least it's very different from physical determinism, because there, in this development of science, there is always the emergence of something new.
Thank you, Marij. John, would you like to come in with a quick question?
Yes. Can you hear me? Well, thanks for a very interesting presentation. I have a question that we've obviously read very much more about Bohm than I have. I'm wondering if you've come across any development of his idea of a super implicate order as a higher level organizing principle controlling the implicate order. It does, of course, as he acknowledges, lead to an infinite regress. But I'm wondering if he abandoned that idea. I suspect it might have been related to some way of getting free will into the system, but it's a very difficult point to answer.
I don't know. I must say, I don't know this. Maybe there's someone else who can answer this question.
I can maybe say briefly that this sort of super implicate order is also something that actually does connect to the Bohm's 1952 papers. Because in those papers, what Marij was talking about, there was this particle guided by the quantum field. But Bohm also does, in an appendix, he talks about the electromagnetic field, and he applies the same formalism to the electromagnetic field. And in that, if you do that, then you, rather than getting a quantum potential, you will get what you call a super quantum potential, which, I mean, we don't need to go into it, but what it does is to produce photons from the field. In a way, it's sort of one way of quantizing the electromagnetic field. And this is actually what Bell already, when Bell praises Bohm, he is referring actually to Bohm's work on this, the way Bohm was doing quantum field theory already in the 1952 papers. And then I think what later on, then Bohm and Hiley, but also Bohm and David Peat, they take this up as they call it a super implicate order now instead of super quantum potential. But it's effectively, they think that it's a very, the way it, if you like, produces explicate elements such as photons is fascinating, and the way it does it. And so, and then they extend this idea to higher levels but it actually, the idea itself has a very precise mathematical description, and it's there already in the 1952 papers, but it's also in the Bohm-Hiley book, Undivided Universe, if you want to check it out.
So it doesn't lead to an infinite regress of.
Well, if you keep adding them, I mean, then you can have a super quantum potential or super. If you keep doing it infinitely, then you will get an infinite regress. But I think at some stage, Bohm was saying, well, this is more a feature of our language. I mean, I don't think he, in the end, believed that any idea could be extended infinity. So it's in the same way, it doesn't need to be turtles all the way down either, because something else than turtles might come as you go deeper. in causality and chance, he also talks about the background, that if you go deeper and deeper elementary particles, you may not find a smaller particle, but you have to take into account the background from which the particles come, which is a bit like the implicate order or, you know, Holland movement or things like that. So I think he wasn't too worried about this infinite regress, but I don't know, maybe he should have been.
Thank you.
Yeah, I think that's good formulation. You don't necessarily have to assume turtles all the way down, but what Bohm does insist on is that you can never assume that you have reached a fundamental level.
Right.
It's always possible that you might go deeper and discover new things. That's what he really emphasizes.
Well, thank you. Thank you both for being here today. Thank you, Marij, for this fabulous presentation. Thank you, Pavel, for putting together this program and for coming and joining us today. And thank all of you for being here, coming in with your questions, actively using the chat. It's been a wonderful session, and we look forward to seeing you tomorrow on our very last session in this series. So look forward to seeing you all then. Thank you both.
Thank you.